Hi everyone, welcome to my Generative AI series. So from this video, actually, we'll be starting with another amazing concept inside Generative AI called vector database. See, if you want to learn, if you want to master Generative AI, if you want to work with the large language model, so this is super important concept you have to first of all master. And this is called actually vector database because see, whatever, let's say data you will be using, whatever documents you will be using, let's say to work with your large language model. So first of all, what you have to do, you have to convert the documents to the embedding representation. I think I already explained like what is embeddings, right? So my model can't take the English input directly. So for this, I have to create some number. Okay, that means I have to generate the embeddings. I have to generate some vector. And after generating these kinds of embedding and vector, we have to store these are the vector to a databases because I have to connect my large language model with these kinds of databases. Okay, so this is called actually vector databases. Okay, I hope it is clear now. So no need to worry. I will give you the entire idea of this vector database, like what vector database is. Even I will also show you the different practical with different vector databases. So here we'll be covering almost all the famous vector databases, whatever let's say people are using broadly in the market. We'll be covering all of them. No need to worry. And guys, to show you this vector database demo, I'll be using one framework called LangChain. So LangChain is a generative AI framework. With the help of LangChain, actually, we can build different generative AI based application. Because inside LangChain, actually, all kinds of vector database functionality are already available. Okay, so that's why I'm going to use LangChain throughout the entire, let's say, a series of this vector database. But if you're not familiar with LangChain, no need to worry. Go through this tutorial and try to implement whatever things I'm implementing. So after this vector database series, I will start the complete LangChain series as well. So there actually will be starting from very basics of the LangChain, even we'll be covering till advanced part of the LangChain. Okay, we'll be learning each and everything. As of now, let's say as a code wise, just try to understand, okay, what are the functionality actually I'm using from the LangChain and try to implement with me. And make sure whenever I'll be installing any kinds of package on my Collab notebook, try to see the version. Okay, try to see the version of that package because today actually I'm creating the video. I know that because this is a completely research field. So some of the functionality they will change in their package and then you will get some issue. Okay, you might get some issue, you might get some error. So make sure whatever, let's say version I'm installing on my notebook, try to also install the same version. And if I'm not mentioning the version, okay, with the package, what you can do. So whenever I will show you the installation, below in the console, you will see the version. Okay, like what is the LangChain version, what is the OpenAI version, what is the, let's say, vector database version. Okay, just try to see the version, try to just note it down and try to install the same version. It will work because see, it's a completely research field. Every day they are updating their package and all. So I know that if you're learning something today, so tomorrow actually they will update that package and you might get some issue. Okay, so that's why I'm telling you guys, always try to use one specific version. Okay, if you're using a specific version, so you won't be having any kinds of issue because you know that this version will work fine. Okay, the code you have implemented. So that's why just try to see the version, whatever version I'm installing. See the console of that Collab notebook. There actually will see all the version has been written, okay, for all the package. So note it down and try to install the same version. Now let's try to see what are the topic actually will be covering through this vector database series. So guys, as you can see here, first of all, we'll be learning about vector database, like the in detail explanation of the vector database, what is vector database, how it is work and all, everything we'll be learning. Then we'll see that why we need the vector database, how vector database works, use cases of the vector database, then some widely used vector database will be also learning. Then at the last of the series, actually we'll be also doing the practical demo with the help of Python and LangChain. As I already told you, we'll be using LangChain framework to work with the vector database. Okay. Now let's try to see what is vector database is. See, vector database is nothing but a vector database is a database used for storing high dimensional vectors such as word embeddings or image embeddings. So I think you already know that we are having lots of unstructured data and higher dimensional data like documents, image, PDF. Okay, then we are also having audios, videos and so on, right? So this is called actually unstructured high dimensional data. So what we have to do inside vector database concept, we just need to first of all convert these are the higher dimensional documents to the higher dimensional vector. You can see we are converting these documents to a vector representation and this vector actually we are storing to the database and this is called actually vector database. Okay, that is why here I have written a vector database is a database used for storing high dimensional vectors such as word embeddings as well as the image embeddings, because I think you already know that inside generative AI we are having textual data as well as the image kinds of data, that means video data, audio data and so on, right? So that is why you can consider any kinds of data, and whenever you are considering any kinds of data, it will have some embeddings and that particular embedding you have to save to the vector database. So this is the introduction of vector database. I think it is clear. Now you can ask me like why we need this kinds of vector database, because we have lots of existing database are available in the market. Now to give you the answer, actually I want to show you one example. So first of all, let's see like why we need this kinds of vector database. Because if you see over like 80 to 85% data out there is unstructured data. Like we have images, we have videos, we have text, and we have audios. Okay, so these are the data, actually unstructured data. So we can't easily store these kinds of unstructured data to the relational database, or let's say our traditional database. Like we have MySQL, then we have PostgreSQL, then we have SQLite. So these are actually relational database, and these are actually traditional database. So we can't directly store. These are the data. So we can directly store our unstructured data to these kinds of relational or traditional database. Okay, why we can't store? I will show you one example. It would be very much clear. So guys, to give you one example, let's take one image data as an example. So let's say I want to store these kinds of dog images to our relational or our traditional database. So if I want to store it, I can't directly store these are the data to our relational database. Okay. So if I want to store it, so what I need to do, I need to create some of the schema. Let's say I have some schema here. I have some table. So in this table, let's say I have one column called animal. Okay, animal. Then I have another column called color. Okay, then I have another column called tags. So basically you need to manually label them to store these are the images. Okay, if you want to identify similar kinds of images, if you want to apply the query on top of that, then you need to create these kinds of schema manually. Now here you just need to set those parameter manually. Let's say animal wise it's a dog. Okay, it's a dog. Then color wise, let's say it's black, or let's say I can, and color wise you can give any color, let's say golden. Okay, this is the golden golden dog. Then we have, let's say, black dog as well. Okay, black dog, you can give anything based on your image actually you are trying to store. Then you also need to assign some of the tags. Let's say this is very cute. Let's say this dog has black eyes. Okay, black eyes. So these are the tags actually we'll be assigning manually. So what happens actually, so whenever you assign these kinds of schema manually, so what happens, let's say you want to query the similar images, okay, from the database. So you just give these are the parameters, so it will return these are the image for you, okay, based on the tags actually you have written, based on the schema you have prepared, right? But again, it's a manual thing. Okay, it's not an efficient way to store our data, and it's not an efficient way to like query out our data, because let's say I want similar kinds of image, so I need to assign these are the labels manually, and it's like very hard task for us, right? So that's why actually we can't use our traditional, or let's say relational database for these kinds of unstructured data. We can easily use these kinds of relational database for the structured data. Let's say we have CSV data, we have Excel data, but for these kinds of unstructured data, it's like very much difficult to store these kinds of data, right? You can store them, there is no issue, but the thing is, like, whenever you will be querying out from your database, let's say you want similar kinds of dog images, at the time it would be very much difficult, because if I, let's say, convert this image to base64 string, so using base64 string I can easily store the data to the relational database. But I'm talking about whenever, let's say, you are applying query on top of that, let's say you want similar kinds of dog images from this database, at the time it would be very much difficult for you to querying out, because it doesn't know like whether this base64 string is a dog image, or let's say it's a cat image, or let's say it's a horse image. Okay, it doesn't know. So there is only one option to filter out these kinds of images. The thing is, like, you need to create one manual schema, like these kinds of tags you need to generate, you need to label out these are the images. Using that actually you can filter out these kinds of data, but again it would be very hard approach, as I already told you, because you need to apply manual observation here. Now guys, I think you already got the idea like why it is difficult to store these kinds of unstructured data to the relational database, because as you can see, image is nothing but it's a pixel, and your relational database doesn't ever know like how to query out similar kinds of images using these kinds of pixel, right? So guys, this is the one major problem with this kinds of relational database whenever we are using unstructured kinds of data. So guys, whenever I'm talking about unstructured data, it is not only image data. So it can be video data, it can be text data, and it can be audio data as well. So guys, to overcome this issue, there is a concept introduced called vector embedding. So let's say we have unstructured data. Let's say we have image, we have text, and we have audios, and it can be also videos. So first of all, what we need to do, we need to apply something called embedding model. Okay, so embedding model is nothing but it's a neural network based model. It's a deep learning model. So using this embedding model, first of all, you will be generating some of the embeddings, or let's say vectors. Okay, let's say this is my image. We have applied embedding model. Embedding model will give you vectors. Okay, like this is the representation of the image. Okay, this is the numerical representation of this image. It can be also applied to the text data. So you see here I'm giving the text data, and this is my embedding model, and it is returning this kinds of vector. Again, you can also put audio data, so it will convert to the numerical representation, and this is the representation of the audio. So here if you see, embedding model is nothing but it's a neural network based model. Here you can use any kinds of embedding model. Let's say we have what to wake, then we have transformer based embedding model as well, right? So these are the things actually you can use. So if you're already familiar with NLP, that means natural language processing, I think you have heard of like what to wake, then you have heard of like transformer embeddings. Okay, and nowadays actually we have large language model based embeddings, like we have OpenAI embeddings, we have lots of open source LLM based embeddings as well. We have Hugging Face embeddings as well. So using these kinds of embedding model, we can easily generate these kinds of vectors and we can store them in a vector database. So guys, this is the entire idea on top of this unstructured data, like how we can store these kinds of unstructured data to the vector database. So first of all, what we are doing, we are just trying to convert these are the unstructured data to the vectors, vector representation. Then we are storing these are the vectors, okay, to the vector database. So guys, here is an example you can see. So let's say we have text unstructured data, and here you can use any kinds of embedding model. So in this case, actually, I have referred this OpenAI embedding model. So it is already trained on GPT model, okay, GPT 3 and 4 model. And if you put these kinds of unstructured data to the embedding model, it will give you this kinds of vector, okay, this kinds of vector representation of all the text actually you have in the documents. Then once you got this vector, actually this vector embedding, then you will be using some vector database. It can be anything, any database you can use. So here you can store one by one, these are the data. Okay, so this is the complete idea of this vector database. Like instead of directly storing our text data to the database, first of all, what we are doing, we are taking help from the embedding model, and using the embedding model, we are trying to generating these kinds of vector embeddings. Then we are storing these kinds of vector embeddings to the vector database. And guys, this kinds of vector database has one beautiful function called similarity search. So using this similarity search functionality, it can return you similar kinds of vector represented in the vector database. Okay, I will show you this similarity search as an example, like how it is doing actually similarity search. Now guys, you got to know like what is embedding, but you don't know like how these embeddings are generated. So to give you one example, I will open my whiteboard and there I will try to make you understand. So guys, I'm inside my whiteboard, and here first of all what I will do, I will take one pen, and here I'll be using unstructured data, unstructured data as text data. Here I'll be using text data to give you the example. So first of all, what I will do, let's create one table here. So let me create one table. So guys, let's say I have taken one table here. So here we are using one embedding model. So let's say we are using one embedding model to convert our text to numbers. So here you can use any kinds of embedding model. You can use OpenAI based, you can use what to wake, you can use large language model based, you can use anything here. Okay, now whenever let's say I have some words here. So let's say I have something called king, then I have something called queen, then I have something called man, and I have something called woman, then I have some let's say monkey. So let's say I have 5 words here. Now what this embedding model will do, it will try to generate some of the features on top of the words. Okay, let's say this is my feature column, features column. Okay, so what kinds of features actually it will generate? Let's say it can generate anything. Let's say it can generate gender, it can generate wealth, it can generate power. Because this is a neural network based model, we can't say like what are the features actually it will generate, because it will generate these are the features based on the back propagation. So it will calculate the loss and all. Based on that, actually it will try to find out the best possible features, okay, for these kinds of work. So here I'm just giving one example, that's why I'm taking these are the features. Okay, but it might not like generate these are the features, but to give you one example, I will be using these are the features. Now let's say it will generate weight, and it can also generate something called speak. Okay, now what happens actually, based on the features, actually it will assign some of the value. Let's say here my first word is king. Okay, now king has gender or not? Yeah, king has gender, and the gender is like male, so it would be 1. And for queen, yeah, queen has also gender, so it would be 0 because queen is a female. So similar wise, man has a gender, so it will have 1. And woman also has gender, so it would be 0 because it's a female. And monkey, let's say it's a male monkey, so I'll assign it 1. Okay, now it will come to the next features called wealth. Okay, now here, and here you can see king has wealth, right? Because he's the king and he has lots of wealth, so it would be, let's say, 1. I'll assign it as 1. Queen will also have wealth because queen is also part of king. And man will also have wealth, but it would be less than king and queen, so let's assign as 0.5. And women will have also wealth but less than man, so here I can give 0.3. Monkey doesn't have any wealth, so I'll give as 0. Okay, now king has power, so I'll give 1. Queen has also power but less than king, so I'll give 0.7. Man has also power, let's say man has power but it's less than king, so I'll give as 0.5. Woman has also power but it's less than man, so it would be 0.2. And monkey doesn't have any power, so I'll give as 0. Now weight, yeah, king has also weight, so I'll give 0.8. And let's say king is a little bit obese. Queen has also weight, so I'll give as 0.5 because let's say queen is slim and all. Man has also weight, so I'll give it as 0.7. Women has also weight, I'll give 0.5. Weight is fine, I think. Monkey also has weight, let's say 0.3. Now king can speak, so I'll give 1. Queen can also speak, I'll give 1. Man can also speak, I will give 1. Women can also speak, I'll give 1. And monkey doesn't speak, okay, so I'll give as 0. Okay, now see guys, beautifully it has generated, these are the vectors. Okay, by generating these are the features. Now let's say if I want to represent king, okay, if I want to represent king, so what would be my king vector? So here, this is your king vector. So king vector is nothing but 1 1 1 0.8 1. So this is the king vector. Now if I want to represent queen, so this is my queen vector. So queen vector would be 0 1, then 0.7 0.5 and 1. Okay, now if I want to represent man, so this is the man vector. So 1 0.5 0.7 and 1. Okay, now let's say if I want to represent women, okay, I think you are getting it, like how we have generated, these are the vector. Now this is the vector of the women, so 0 0.3 0 0.3 and 0.2 0.5 and 1. Okay, now let's take one 2D dimension, okay, and plot these are the vector and try to understand like what will happen. So let's say here I will take one 2-dimensional space. So let's say this is my 2-dimensional space. Okay, so this is my x and this is my y. So if you plot all the vector here, okay, if you plot all the vector here, you will see king and queen, king and queen will appear to the similar. So here let's say this is my king and this is my queen. Okay, so what will happen whenever you will plot these at the vector to the 2-dimensional space, or let's say 3-dimensional or any dimension, okay, you will see king and queen will appear like very close together. Because if you see here, okay, if you see here, as per the features, if you calculate the number, if you calculate a distance between these are the vector, you will see this distance would be like very less. Okay, that's why king and queen would be appearing very closely together. And here man and woman, let's say this is my man vector and this is my woman. Okay, this is my woman. So these two vector would be appearing closely. And here if you see here, there is another vector called monkey. Okay, monkey will appear completely different from these are the vector, because monkey is a different entity here. So let's say this is my monkey. Okay, now if I show you, see, so it has built one cluster. So this is one cluster, this is another cluster, and this is another cluster. Okay, now if you see here, using this concept called vector embeddings, we are easily getting these are the similarity score. Okay, similarity vector. So now if I want to extract any kinds of vector, okay, let's say I want queen. Okay, I want queen. So it will go to this cluster and will return this vector. And let's say not only queen, let's say it would be, let's say I want something called princess. Okay, I want something called princess vector. So what will happen? It will come in this cluster, because if you calculate the vectors, okay, of the princess, you will see it will have these are the features. Okay, it will have these are the features related to the king and queen. Okay, so now this princess will appear here. So that's how actually this embedding model works actually. So it will first of all assign some of the features. Based on that, it will generate these are the vectors, and it will plot these are the vectors to the higher dimensional space. So here in this case I have taken 2-dimensional space, but it might be 3, 4, 5 and so on. Okay, based on your dimension of the data. So whenever I'm using unstructured data, whenever I'm using real world data, so dimension might be vary. Okay, it might be millions dimension, it might be 1,000 dimension. We can't say like what are the dimension it will have, but as a visualization we can only show 2D space here. Okay, so this is the complete idea, guys. I think you got it, like how these embeddings model are working. Okay, and how it is generating these kinds of vector. Okay, now here in this case actually you have lots of embedding models. So we have OpenAI embedding model, and this model is trained on GPT. Okay, GPT model, I think you have heard of GPT model. Then we have something called Hugging Face embedding as well. Okay, Hugging Face embedding. So it is already trained on, let's say, lots of open source LLM. Okay, that means large language model. Then we also have something called Llama. Okay, Llama 2 embedding. I'll be discussing like what is Llama 2 and all. Okay, as a open source model. Then we have something called Google Palm embedding. So these are the open source embedding you can directly use. So this is from Facebook research. Okay, and this is from Google research. Okay, and this one is paid, because if you are using OpenAI embedding and OpenAI model, so you need to pay. This is completely paid, and these are the things are free. Okay, these are the things are open source and free. But to get the Llama 2 access, actually you need to like send some information, then they will give you the access. I'll tell you like how to take this Llama 2 access and all. Okay, everything I'll be discussing about. Don't worry about, like, just try to stay with the video. I'll be discussing each and everything. So guys, I hope you got the entire idea, like how these embeddings models works. Okay, and how it generate these kinds of embeddings as a vector, right? So guys, here I kept another example. If you just see this example, your concept will be very much clear. See here, I have these kinds of words, okay, and we are using these kinds of embedding model, and we are generating these kinds of vectors. And if we plot these are the vectors to the 2D dimension, so it will look like that. So let's say we have this 3 word, we have this 3 word, and we have this 3 word, and we are getting different vector. And this is the cluster. Okay, this is the cluster of each of the words. If you see here, king, man, women, it's appearing in the same cluster. Then apple, banana, orange is appearing to the another cluster, and football, golf, and tennis, it's appearing in the another cluster, because this is related to a person. Okay, person, and this is related to fruits, and this is related to sports. Okay, that's why this cluster is different. Now I think you got it, the vector embeddings, like how this vector embeddings looks like and how it is generating. Okay, I have given you the entire idea. But one issue actually with this vector embeddings, which is nothing but whenever you are getting any similar kinds of vector, it is applying something called distance formula. I think you have heard of like distance formula. We have Euclidean distance. Okay, we have Manhattan distance, or let's say we have something called cosine similarity score as well. Okay, so using these are the equation, actually it try to calculate the similar kinds of vector. But again, if you see here, it would be very much time taking, because it will calculate with respect to one by one all the vector, then it will give you the similar kinds of vector. So the main problem is like the time. If you are using this thing directly, so it will take lots of time to give you the similar kinds of vector. So to overcome this issue, actually they propose something called indexes in the vector database. Okay, like we call it as vector indexes. So what is vector indexes? So let's say whenever we are having these kinds of unstructured data, we are applying these kinds of embedding model, and it is generating these kinds of embedding. Okay, so on top of this embedding, where what it's trying to do, it is trying to add some kinds of indexes. Okay, so this indexes is nothing but it's a data structure. It's one kinds of data structure actually. So what it will do, it will find out similar kinds of vector and it will assign some of the indexes. Okay, and it will make some cluster kinds of thing. So whenever, let's say, you have any new data, first of all it will see like which indexes actually it lies this data. So in that index only it will search that query. So to understand this, let's say this is my example. So first of all, let's say it has assigned these kinds of indexes. Now you have one new data. Now first of all it will see like which cluster actually this is lies. Okay, so it will go to that cluster, then it will return the similar kinds of vector with respect to the new data you are giving. Okay, instead of searching to all of the clusters. So this is the idea of these indexes in this vector database. Now using these indexes to our vector database, it's like very fast. Now whenever you are asking any kinds of query to the vector database and it is returning any kinds of vector, so this process time would be very fast. Now guys, I hope you got the entire idea like what is a vector database and all about, and what is embeddings and all about. Now you can tell a vector database indexes and store vector embeddings for faster retrieval and similarity search. So we used to use our traditional database to directly store our data, but in the vector database, first of all we try to convert as vector, then we try to store them to the vector database. Okay, this is the complete idea. Now guys, let's discuss some use cases like why this vector database is useful, like what are the use cases are there. So as you can see, it will help you the long term memory for the large language model, because it is storing all of the data as a vector to the vector database. So whenever you are connecting these kinds of large language model to the vector database, so it can be used as a memory. Okay, memory of your large language model, like long term memory. And it can also perform something called semantic search. I already told you how to perform the semantic search using the formula and using the indexes and all. So search based on the meaning of the context. Let's say if you're giving something called, let's say, king and queen, so it will not only consider the text you are giving, it will also consider the context, like what is king, what are the features of king, what is the features of queen. Based on that, it will give you the similar kinds of vector, okay, as a output. Then it can also perform something called similarity search, as I already told you, like on the text data, image data, video data, or let's say audio data. Let's say I have one image, let's say dog image. I will tell hey, just give me some dog images, okay, similar kinds of dog images. So it will first of all try to see the vector, okay, similar kinds of vector, and it will return the similar kinds of representation of the dog to you. Okay, so we call it as similarity search. Then it can be also used in the field of recommendation system, because as you already saw, like if you are having these kinds of vector together, and it can perform similarity search. Let's say I want to build something called recommendation system. So let's say I'm asking for like food related content, so it will suggest me food related content only, okay, using these kinds of similarity search and all. So guys, this is the entire idea of this vector database, and these are the use cases actually you can consider, okay, inside this vector database. So guys, I think so far everything is clear. Now let's try to see some widely used vector database. So you can see we are having ChromaDB, Weaviate, then Fias. So Fias is implemented by Facebook AI. Then we are also having Pinecone, then Neo4j. Neo4j is a graph-based vector database. Okay, so these are the actually very common vector database people are using in the market, and is like very famous vector database, okay, in the market right now. So here we'll be exploring all of them one by one. So in the next video, we'll try to see how we can use ChromaDB, and ChromaDB is a local vector database, and this Pinecone, Weaviate, Neo4j, it's a cloud-based vector database. Okay, and here is another vector database. You can see Fias. Fias is also a local vector database. That means if you want to, let's say, store your data as a locally, so what you can do, you can use ChromaDB or Fias, and if you want to store them in the cloud, you can use Pinecone, Weaviate, or Neo4j. Okay, so guys, let's start the practical from the next video. Thanks for watching.